Right, so the presentation is immunofluorescent agglutination reaction as a way to control secondary bacterial infections and developing homologous vaccines. I guess you all know what the agglutination reaction is, but I am sad because, you can say that I'm sad. Professor Gromov mentioned that in the past everything was better, and there were lots of versatile labs. For instance, you can isolate a strain, then do the serum tests, and then the immunofluorescent agglutination reaction. However, the number of test systems in your fridge limits the abilities of the current labs. If you're a small lab, you just have 3 sets. If you're a large lab, you have over a dozen. Can we diagnose stuff like that? Of course, the answer is no, and we will never have tests like that. There are there are thousands of bacteria and pathogens that can result in infections, and you will never have that many test systems. Can we do an ELISA test? Can we develop an ELISA test for all of the infections? So of course, the answer is no. And there are lots of outstanding issues that we don't need to solve because, if we sell vaccines to poultry farms, we can limit the number of tests depending on the number of vaccines. If you don't have a vaccine, why would you need diagnosis test if you cannot do anything about that? But actually, can you put up your PPT stack on the screen? Right, so what I'm saying is that you can use immunofluorescent agglutination reaction based on the strains that you isolate, and that helps you solve the diagnosis problems in general. And in particular, the homologous vaccines, which means that we can bring up these labs, our labs, to this level, and it will not be expensive. Homologous vaccines can be developed by a microbiology lab. Much depends on the qualifications of a microbiologist. If we're not talking about recombinant vaccines,